So when we talk about the tangent function, the parent function for the set of all possible tangent functions is just tan of x. Now, as you might have experienced, tangent is not defined everywhere. So it turns out that tangent's going to have some vertical asymptotes. The domain, we'll say, is the set of x's such that x is not equal to n times pi over 2, where n is an odd integer. And the range for tangent is all real numbers. So you see that tangent is like a fundamentally different looking graph already than sine or cosine was going to be, right? Remember, sine and cosine was defined for all real numbers, and its range was stuck between -1 and +1. When we talk about the symmetry for the graph of cosine, or I'm sorry, the graph of tangent, tangent is an odd function, which means that it has that 180-degree point symmetry about the origin, which, thank goodness, we came up with a different phrase for that, because that's a mouthful. Odd seems quite a bit easier to deal with. The midline is y equals 0. The period here is pi, so the frequency is 1 over pi. Make sure you pay special attention here that the period for tangent is not the same as the period for sine or cosine. That's a common mistake that students make. And what other descriptor here is missing from this list? Amplitude, right. Tangents don't have amplitude, so let's just go ahead and graph tangent of x just to get a picture of kind of what it is that we're interested in here. So this is what the graph of tangent looks like. So you can see that there's vertical asymptotes that happen predictably. Everybody kind of see those? And the reason that we don't talk about an amplitude for tangent, if you remember the definition for amplitude, it's the distance between an extrema and the midline. If I look at the graph of tangent, no extrema here, right? So there's no global or local maxes or mins, so it makes no sense to talk about amplitude for a tangent graph. Okay. So how are we going to come up with the key points for tangent or analyze tangent? Well, remember back to our kind of naive right triangle definitions for these trig functions. We said tangent was opposite over adjacent. We said that sine was opposite over hypotenuse. And we saw that cosine was adjacent over hypotenuse. If I take the tangent equal to opposite over adjacent, and I multiply this by 1 over the hypotenuse to the top and bottom of this fraction, I can do that because I know the hypotenuse is always non-zero, and because I'm doing the same thing to the top or bottom, it's the same as multiplying by 1, right? If I do that, I get opposite over hypotenuse in the numerator and adjacent over hypotenuse in the denominator. But I know that opposite over hypotenuse, that's really just sine, right? And the denominator, I have adjacent over hypotenuse, but that's just cosine. So I can say that tangent is really just sine over cosine. Is everybody okay with that idea? So now that I have established that tangent is sine over cosine, we can answer some questions like, for example, when is the tangent of x undefined? Well, I know that something is undefined anytime the denominator is equal to 0. Would you agree with that? So my answer is whenever cosine of x is equal to 0. And if I think back to cosine of x is equal to 0, the values of x in which that's true are pi over 2, 3 pi over 2, yada, 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 kind of in both directions. Everybody's okay with that? Notice that this matches up exactly with my description of the domain earlier. So we can say that we can write it this way, or like we did with the domain, so either of those two descriptions are equivalent and mean the same thing. Whether you want to think about it as pi over 2 plus pi k, where just k is any integer, or if you want to think about it as pi over 2 times k, where k must be an odd integer, either of those are okay. They mean the same thing. Everybody okay with that idea? So maybe I want to know when the tangent of x is equal to 0. So I know the tangent of x is equal to this fraction. And a fraction is equal to 0 whenever the numerator is 0 and the denominator is non-zero. So in our case, I know tangent is equal to 0 whenever sine is equal to 0. Well, I know for this, sine was equal to 0 every pi units. So I can say that tangent is equal to 0 when x is equal to pi k, where k is just some integer. Okay. So at this point we should have a decent understanding of tangent, if we're going to be graphing tangent, I need to come up with my reference points. So, if I look at the graph of tangent, and I want to try to pick out some reference points, basically I just need to be able to graph one of these pieces, right? So one of my reference points is going to be this vertical asymptote. And then I want to get one reference point on the lower arm, one reference point that's on the midline, one reference point that's somewhere here on the upper arm, and then the asymptote that ends that cycle. Is everybody okay with that plan? So I'm going to have 5 reference points. So my first reference point is negative pi over 2. And I know that that was on my list up here as a place where the graph is undefined. Now the next x value I'm going to use is negative pi over 4. Why is that of interest to me? Well, if I go and I look at my unit circle, and I wait for it to load, there we go. Negative pi over 4 is here. Everybody agree with that? And to calculate the tangent of negative pi over 4, I do negative root 2 over 2 divided by root 2 over 2, which is just negative 1, right? That's convenient. And then we'll have 0, 0. Again, I know 0 is one of those points that are going to make tangent equal to 0. Similarly, I'm going to use positive pi over 4, and that gives me a value of 1. And then positive pi over 2, that's undefined. Pretty okay there? So now I have everything I do to, or everything I need to do some graphing problems. So let's say I wanted to graph negative tangent of x over 2 on the interval from negative 2 pi to positive 2 pi. First thing I'll do is I'm going to rewrite tangent in the form where I can identify the values for a, c, h, and k. Everybody okay there? From that, I can tell that my period is going to be 2 pi. Why is my period 2 pi? So that's the thing I want to point out. The period for tangent is not 2 pi times the absolute value of c, because the fundamental period for tangent is not 2 pi, it's pi, so the period formula changes there for tangent appropriately. For tangent, the period is pi times the absolute value of c, rather than 2 pi. Everybody okay with that? So pi times the absolute value of 2 is 2 pi. So that means my frequency is 1 over 2 pi. And my midline is still y equals k. So y equals 0. So I'll write my transformation map. So I have cx plus h, ay plus k. And I'm going to apply this transformation to my key points, or my reference points. So again, when I write UND, that's just short for undefined, not underwear. That's a joke. We're supposed to laugh at those. Yes. We'll talk a little bit more about like what the expectation is, but most of these points you can read off the unit circle. We'll talk about how we do that again. And I would surely give you the unit circle. So to me, I wouldn't memorize them. I just like know how to find them, which seems easier to me than like memorizing a list. But if you do a bunch of these graphing problems, you'll probably end up memorizing them just because like you do it enough times. It's like, okay, I remember what these are. All right. Anyways, so I go ahead and I plug this in. So 2 times negative pi over 2 is negative pi. What's the negative of undefined equal? It's just undefined still, right? If I do anything to undefined, what is it? Undefined. So 2 times negative pi over 4 is negative pi over 2, and then negative of negative 1 is positive 1. Here's 0, 0. 2 times pi over 4 is pi over 2, and then negative of 1 is negative 1. 2 times pi over 2 is pi, and anything I do to undefined still stays undefined. So now I'm going to draw my graph. So I'm going to put my tick marks every pi over 2 units. Seems appropriate to me. So the first thing I'll do is at negative pi, undefined, I'll draw my asymptote. And at positive pi, I have undefined, so I'll draw on that asymptote. I like to draw my asymptotes first. And then I'll plot those 3 key points in the middle. So at negative pi over 2, I have 1, 0, 0, and then at positive pi over 2, I have negative 1. So to draw my graph, I'll follow the asymptote, I'll go through those 3 points in the middle, and then follow my asymptote again. Everybody okay with that? And now I'm just going to kind of extend my graph. So over here, I would have there and there. And over here, I would have this one and this one. So there's my graph of tangent. Everybody feel okay there? Really the same thing as what we did in the previous lessons, right? You just have new key points and the shape of the graph looks a little bit different, but it's still kind of the same thing. It's not so different. What if I wanted to go from a graph to an equation? So right away, when I look at this, I should be able to tell that this is a tangent graph, right? So what I'm looking for is to find my values for A, C, H, and K, so that I can plug them into my general form for tangent. So what I'm going to look for first is my value for K. I'm going to find the value for K by just locating the midline on this graph. So where do you think the midline is? That looks like it, right? If I look at the bend in the graph, that kind of splits where it's curving up versus where it's, or curving down versus where it's curving up. Kind of splits it there. So this is y equals -1 as my midline. So I can say that k is -1. Everybody okay with that? That was pretty easy. Didn't really have to do much to do that. I just had to kind of look at my picture. I know for tangent, one period is going to be from vertical asymptote to vertical asymptote. So if I measure that distance, that's going to be positive pi over 4 minus negative pi over 4, which is just pi over 2. And then since the period for tangent is pi times c, or pi times the absolute value of c, I know the absolute value of c is just 1/2. Everybody okay with that? So to figure out my value for A now, what I'm going to do is I'm going to look at the section of my graph on my midline, from my midline point to my asymptote. I'm going to look at that little section. I'm going to split that section in half and then look at how far that is from my from that place on the midline to the graph. If I look at that, how many units do you count there? That's just 1 unit. Everybody okay with that? That's usually the easiest way to kind of locate that value for A. Is just use your eyeballs rather than try to make a calculation. Is that okay? And if you have the whole graph, it's not so bad. Maya? Okay. All right. So the last thing we need to do is figure out our value for H. In doing so, that'll also determine the signs for A and C, which we still also need to square. So for tangent, I know the parent function has a midline point at 0, 0. And our transform function also has a midline point at 0, 0. But I still need to sort something else out before I can go forward. I need to look at the graph surrounding this midline point. So if I looked at the transform function, before the midline point, my graph is pointing down, and after the midline point, my graph is pointing up. So I'm going to write it like that with arrows, because I have it down, my arrows pointing down before the midline point and pointing up afterwards. And I want to compare that to my parent function. So if I look at my midline point here, left of the midline point, the arrow is pointing down, and right of the midline point, the arrow is pointing up. So when I write my midline point, I'm going to include kind of the surrounding neighborhood of what the function is doing. Because in comparing what's going on before and after that midline point, I can make a judgment about what the value of A is. Since those match up, I know that no reflection has taken place, so I know that the A and C that I'm looking for are positives. Everybody okay there? All right, still need to find H though. So we're going to find H the same way. I have a point on my parent function. To get to a point on my transform function, I use my standard transformation map, Cx plus H, Ay plus K. So if I take C times 0 plus H, I plugged in 0 there, that should equal the x-coordinate on my transform function. So that's the 0 there. And so what does that tell me then? H is 0. So I have y equals 1 times tangent of 1 over 1/2 is 2, x minus 0 minus 1. Or if you wanted to clean that all up, it's just tan of 2x minus 1. Then? So I just plugged in my parent function, x-coordinate, and that should equal my transformed function's x-coordinate. So C times 0 is 0, 0 plus H is H, so I have H on the left-hand side just equal to 0. Cool beans? I think so. That's about the gist of it here, guys. Let's stop here for, I guess we meet on Monday. Can you guys work on 15 to 26 for me?